digital depths, he plays for keeps. A toast to the nights with tricks up his sleeves. In the silence, the midnight wrecker creeps. Oh, the midnight wrecker.
Welcome, ladies and gentlemen. Have you ever wondered how tiny particles in a solution can come together to form beautiful sparkling crystals? What if I told you that you can create your own salt crystal right at home? In this video, we are diving into the fascinating world of crystallization as we grow beautiful sodium chloride crystal right before our eyes. Stick around as we explore while conducting an exciting hands-on experiment that you can try at home. Now, before we get started, let us gather our materials here. You will need 2 plates, a big plate and a small plate, a tablespoon for stirring our salt solution, a tea strainer, a bag of stable salt, and last but not least, our glass. First, we will prepare our saturated salt solution. Begin by boiling some water. Make sure it is boiling, otherwise we cannot make salt solution. Next, put a tablespoon of salt first into our glass. Then, put some boiled water into the glass and stir the solution until all the salt we just put has dissolved. Now, gradually add table salt while stirring. Keep adding salt until no more dissolves in the water. Here, we can see that our solution cannot dissolve any more salt. Once you have done stirring, wait for a while and let it cool first. Next, pour the saturated solution into the small plate. Use tea strainer while pouring carefully your saturated salt solution into the plate. Now, here comes the waiting game. Place your plate in an undisturbed location and let it sit for 2 or 3 days. As time passes, you will see crystals starting to form at the bottom of the plate. And there you go! Look at our beautiful salt crystals that have formed. These formed crystals were collected from the bottom of plate just now. As you can see, the size and the shape of this crystal are pretty different, right? Well, this is because of some factors that have affected our crystal shape and size. Later we will explore the reason behind this and discuss together. Here is our perfect formed face-centered cubic structure of sodium chloride crystal. Beautiful, isn't it? Now, let's take a closer look at the crystal that we have formed. As you can see, we have some impressive sodium chloride crystal measuring between 0.4 and 0.5 centimeters with the uncertainty of 0.05 centimeter in the length. That's actually a great size for a home experiment. Now, you might be wondering, why is the size of these crystals is very insignificant? Well, the size and the shape of the crystal can tell us a lot about the conditions under which they form. Larger crystals typically indicate that the solution was stable and that the sodium ions and the chloride ions had enough time to arrange themselves in an orderly fashion. Alright, now that you have watched me making sodium chloride crystal in practical. So for those who are watching this video, you might be wondering, how do I form sodium chloride crystal in a microscopic view? Right? Here we will together delve into the concept behind of how does the sodium chloride crystal can be formed. Alright, so there is a process at which we form this sodium chloride crystal that is also known as crystallization. So what is exactly crystallization process? So crystallization process is where the solid forms from a solution or a gas where the atoms or molecules arrange themselves in a highly ordered structure. Okay, so this process can occur under various conditions and it is also critical in both nature and industry. So for our case, it is critical in culinary industry where they make use of the sodium chloride crystal for their cooking. Okay, for those of you who don't know, sodium chloride crystal is also known as table salt, right? So during this process of crystallization, the atoms or molecules of the substance will arrange themselves in a highly ordered 3-dimensional lattice structure, in which will minimize the overall energy of the system. So this structure formation results in the creation of distinct crystal shapes and properties. So we know that sodium chloride is formed through ionic bonding, which occurs when the sodium atom and the chloride atom interact with each other. So when we study in high school, we know that sodium is an electropositive metal that has 11 electrons, which, to be more exact, it has 2 electrons in the first shell, 8 electrons in the second shell, and last shell, which is the outer shell, the sodium atom has 1 electron. Okay, so in order for this sodium atom to achieve a stable electron configuration, sodium will lose 1 electron from its outer shell, which result in the formation of a positively charged sodium ion. So conversely, chlorine is an electronegative non-metal with 7 electrons. To be more exact, the first shell, chlorine atoms has 2 electrons, second shell it has 8 electrons, and the last outermost shell has 7 electrons. So in order for chlorine atom to achieve stable electron configurations, chlorine will gain 1 electron to complete its outer shell, which transforms itself into a negatively charged chloride ions. So bottom left here, you can see that that is where the half equation and ionic equation that is used for us to understand the formation of sodium chloride. So from this diagram, you can see that the transfer of this electron from sodium to chloride will create an electrostatic attraction between the oppositely charged ions, which results in the formation of sodium chloride. Alright, crystal structure of sodium chloride. Okay, so as they bond with each other, this result a face-centered cubic or FCC structure. So in this arrangement, you can see that the green color is the chloride ion and the purple color is the sodium ions. Okay, so each sodium ion is surrounded by 6 chloride ion. You can see in this diagram here, the top one, the bottom one, left, right, front, and behind of them. You can see that there are a total of 6 ion of chloride ions surrounded by sodium ion. Okay, so each chloride ion is also surrounded by 6 sodium ions. So these 3-dimensional arrangements will create a highly stable structure due to the maximized ionic attractions. Okay, here we will discuss 2 methods of crystallization, which is the evaporations as well as the cooling method. Okay, so for evaporations, this is one of the most common for us to form the salt crystal, where a solution or the sodium chloride solution is exposed to air. The water will begin to evaporate. So as the solution evaporates, the concentration of the dissolved sodium chloride will increase until it reaches this 1 saturation point. So beyond this point, as more water leaves the solutions, the sodium and chloride ions begin to bond together and solidify into crystal. So the rate at which evaporation occurs will significantly affect our crystal size and shape. So slower evaporation allows for larger crystal to form, as ions has more time to arrange themselves into an orderly lattice. From here, the factor of affecting our crystal growth is the temperature as well as the humidity of the surrounding. Alright, the second method of crystal growth is the cooling method. Okay, so this happens when our saturated sodium chloride solution is cooled. Its solubility or its capacity to hold dissolved salt will decreases. Okay, so as the temperature drops, the sodium chloride will begin to precipitate out and crystallize, because as the temperature reduces, it will reduce the kinetic energy of the sodium chloride molecules. Thus, the excess dissolved sodium chloride cannot remain in solution and it will begin to precipitate out as solid crystal. That is all from me. Thank you for watching and I hope you enjoyed.